now we are moving OAuth security, and we also have gone through the content level security by using our XML threat protection, JSON threat protection, and we understood this regular expression policy and all. Now we are moving to transport layer security, how Apigee supports that. So Apigee has support for TLS as SSL. As you already know that when we deploy the API, we have option of your virtual host when we have a secure virtual host, and if someone want to create one more virtual host for a secure socket layer HTTPS, we can easily create using Apigee. Okay, so when we talk about SSL and TLS, so SSL and TLS both are the same thing, only that now SSL is no more used. Everyone use TLS. So people use the word interchangeably. They use SSL or TLS, but right now SSL is completely obsolete and TLS is used. So HTTPS basically is not SSL. HTTPS is TLS. Only difference between SSL and TLS are it is the same thing in terms of concept. It's everything same. TLS just uses stronger algorithms and lot bigger key and secret pairs, so it is more complex to hack as compared to SSL. SSL had some weak encryptions and all, so because of that now TLS has replaced SSL, and the latest version people use the most commonly is TLS 1.2. okay, so previously there was SSL, but people used to hack even SSL because the encryption was very weak in the SSL. So now people use TLS because TLS has very strong encryption, but SSL and TLS are the same thing. Only difference is the algorithms and your key and secret pairs. So the encryption keys, are very big in size, so it is not easy to decrypt those or hack those. Okay. In normal scenarios, Apigee supports both one-way TLS and two-way TLS. One-way TLS is when a client doesn't have to do authentication, only server is available on HTTPS. Okay, client doesn't have to be on HTTPS. The best example is your Facebook, Google, and everything. Whenever you hit your Facebook, your Gmail, or Twitter, or whatever, everything is on HTTPS, right? Because you don't use HTTP there. So you verify the server of Facebook. Your browser doesn't have to present any kind of authorization to server. So only your server is authorized by your browser. So that way server will present its certificate and your browser internally authorizes and make sure you have this certificate from Facebook is authentic, it is pretty much fine and I can trust it, and then the data transfer happens in a encrypted manner. Okay, so that is the one-way TLS. So anything which you hit on your browser, because they don't have to verify your browser because they have like millions of browsers and everything are accessed every time, they cannot keep verifying this thing, but your browser always verifies the server so that you know that okay, whatever your username, passwords and everything that you are going to do, it is encrypted. Okay, so they don't have to do anything. Okay, so one way is when your client verifies server but server doesn't have to verify client, that is one way TLS. So that is why when we create virtual host secure on Apigee, when we have the secure virtual host and you are hitting that from your browser or you are hitting it from your Postman, server doesn't have to verify the certificate from Postman or certificate from your browser because they don't present any kind of certificate to verify. Okay, only Apigee provides a certificate for that particular host name and your client verifies, and then you when your client verifies it and feels it is good, then the data transfer happens. Okay, in an encrypted manner.
Okay, so that means the certificate is part of the link itself.
Yes, the certificate. So the way it works is, yeah, we have all this in this thing. We'll go through that as well. So we'll explain you that concept even better when with the diagrams. Yeah, I remember that there were diagrams. Okay. So yes, basically when the data transfer happens, the first step is to verify the certificate from the server. Okay, and yes, that happens internally. You as a end user or whoever is going to use the system, we never see that. Okay, it is completely internal. Okay. Okay, for us we just see okay the browser, it is everything we are able to hit. Sometime if that is why sometimes people if there is something wrong in the certificates and all, then we always get a exception that okay they cannot trust certificate or cannot trust this thing on you, and then you have to click on that okay proceed anyway or whatever, and then it goes on there. So that's why. Okay. Now then there is a stronger so in that one-way TLS, it is only server that is verified by client. Okay, now in sometimes when the system needs more security, you also have to verify client. So then that is achieved by two-way TLS. So client has to verify server, and then server also verifies client. Okay, so that's how this two-way TLS is implemented. All right. So that two-way TLS cannot be implemented for a browser-based apps for obvious reason. You cannot verify all the clients who are going to hit you, and there will be millions of clients and
Yes,
all.
correct.
But
Yeah.
all the B2B applications, okay, all the B2B applications or all the internal applications, your internal systems can verify other clients by two-way TLS because it is all internal. So you know that there will be 10 kind of systems that I'm going to interact with, or 20. So there is a finite. So you know that there is a very less number of systems that you are going to interact. Then you do two-way TLS. Okay. So it enhances the security. So you as a client verify the server, and server also verify the client. So two-way TLS is mostly implemented between the APG and the target system. Okay, so two-way TLS is the ideal, and that is the best way. And we also recommend always that whenever there is a target system and you want to communicate with APG, you always implement two-way TLS as much possible. Okay, so that because that is the best way of security and authentication. Okay, to backend, we prefer and we recommend using two-way TLS, and that is where it is the most commonly used. So that target system or the downstream system will only have APG as your client, right? So you can have a two-way TLS in between those two.
Yes, in two-way TLS, okay, client needs to install any certificate explicitly,
Correct.
or otherwise
Yes.
automatically it will be.
Yeah. So there has to be a manual installation. Usually operations dash does that. Okay. So
Okay,
the
okay.
operations team who are managing, they usually do that. So they install your APG certificate on their system, and obviously APG will install their certificate on this thing. Okay.
Okay,
So there
fine.
is a concept of key stores. So key stores are used. So key store and trust stores are used to do all this thing. Okay.
Yes, yes, yes.
So for now, when we are going to use HTTPS, okay, or one-way TLS to hit any server, we should still never use the passwords and all in your query parameter. For obvious reason, if it is in a query parameter, many times what happens, the logging mechanism or the logging systems, they try to store the complete URL. And if they are trying to store the complete URL, they will also store the password or sensitive data. So that is why even when someone is using HTTPS, you should never send passwords in the query parameter. Okay, password should be sent in the payload. So either you send in as a form parameter or you send it as a in the JSON. Okay, so you never send passwords or any sensitive information as a query parameter. All right.
Okay.
One-way authentication, the way it is like the client will authenticate to edge. Client doesn't know what is the target, and it doesn't need to know worry about that. In Apigee, edge will deal with the target. Okay, the same thing which we discussed just now. So in the one-way TLS, it is obviously server validation. So on client validates the server, and server doesn't validate the client. So server has to present its certificate. Client doesn't have to present certificate. Client will just see the domain name which is coming and the domain name which is given in the certificate. Certificate will contain some information, server domain, when the certificate is going to expire, and all those stuff, what is the encryption algorithm and everything that it will check. So client verify the certificate, and then it is, if it is certificate is valid, then you verify, then it is done. Now how server verifies the client? Because client has verified the server, now server has to also verify the client, and server verifies the client using obviously OAuth or basic authentication, right? So client has to present the token, and server verifies the client using those tokens. Correct. So when we implement one-way TLS for browser-based apps, so client has to verify server using the TLS certificate, but server verifies the client using the tokens, right? So you have the correct and valid token, then you can hit the API. If your token is not valid or your client is not valid, then you discard the request. Okay, so the for one-way TLS, we always implement OAuth or basic authentication, these kind of things when there is a one-way TLS. All right, so that way you also have to verify a client. There is a one way to identify who is making the request. All right, but in two-way TLS, you don't have to pass all these OAuth tokens and all. Okay, so when Apigee talks to target, okay, or the two-way TLS is there, then server presents its certificate and client verifies that, and client also has to present the certificate, so server also verifies that. Then you don't have to worry about the OAuth tokens and everything. Okay, so
Yes, yes.
then there is no OAuth token or anything is possible. It is just server certificate to certificate verification, and that is once it is successful, then you know, okay, that is fine. All right, so that's why,
Okay.
that is the reason why we need OAuth and all, because we cannot verify the client using the certificate, because there will be millions of clients and you cannot install those millions of certificate there, right? It is very lot easier to use the basic authentication or client ID or OAuth to verify them. Okay.
Okay, so that means in two-way TLS, no need to go for the OAuth, right?
Correct.
This is
Yes.
directly certificate to certificate verification. Here,
Yep.
server means it is APG server, right? So
Yes.
it's
Platform.
not
We are
target
talking about the platform. Yeah. Apg server. Yeah.
APG. Okay, so client means requester. That means requester who
Yes.
sends the
Either a
request.
browser or your Postman. Yeah. Browser, Postman, or any Android app or any web app. Yeah.
Okay. Yes, yes, yes. Then what about this APG to target system? That is
So in
the
target
that is
target becomes server and APG becomes client. Yeah.
okay. Okay. So that means here two passes will go, right? In
Yeah.
first pass, client to server, that is APG server, and in
Yeah.
second pass APG to target server.
Yeah. Perfect. Yes.
Okay,
So
but finally the verification will be in APG itself,
yes, so
right?
in APG, we verify the client using OAuth tokens, okay, and then
Okay.
we remove the tokens and we don't have to worry about that token anymore, okay. And then what happens in most of the cases, server and APG will have a two-way mutual authentication enabled or two-way TLS enabled. So APG will, whenever APG makes a call, APG will present its certificate to the backend API target system. The target system will use it. Usually targets have installed all these on their load balancer, so target would have some load balancers, or any
Okay.
proxy server installed. Okay, on the proxy server layer, mostly they most common is like Nginx and all. They use Nginx or any load balancer, systems and all, and there they manage all the client certificates. So APG we when we generate our certificate and all, we give them our certificate, and they someone from the operations team from their side, they will install our certificate on their load balancer, load balancer level or whatever. Okay, so
Oh,
then it is verified. Okay,
yes, yes, got it.
so that is now as we talk about certificates. So now whenever APG has to make a call to server and APG has to present a certificate, all the certificate which APG has to present to the backend, okay, certificate and private key, those are stored in the key store. Okay,
Okay.
so certificate and private key are stored in the key store. All these things which APG has to talk to backend. Okay, now APG also has to verify the backend certificate, right? So backend certificates are stored in the trust store. Okay, so APG certificates are all stored on the key store. Okay, and backend certificate, the target certificate, which APG has to trust. Okay, this is the trusted target. Their certificate start stored in the trust store. Okay, so
Okay.
APG provides a very nice way from the UI where you can create a key store and trust store, and you can store easily using those. Okay, so from the APG UI itself, you can easily upload and download certificate and put it there. So we don't really have to understand all the operations activities, and we can simply put from the UI. We can put it there, and there is a management API call, and people can also use management API call to upload the certificates into trust store, or upload a private key and certificate in a key store. Okay,
Okay, fine.
so just a graphical representation of how it works. So client has made a call to your server. Okay, client makes a call, then server has its certificate. Server will present the certificate on the second step. Then APG or the client, sorry, client verifies the certificate from the trust store. Okay, so okay, it will verify, okay, this server is a trusted server, and then client will make a call to access all the data. Okay, so that's how it works. Now what happens is, in case of two-way TLS, the client will have a key store. The client will maintain a key store. This is key store will have the private key and certificate of the client. Okay, and server will and client will maintain a trust store. The trust store will have the certificate of the server. All right, and server will have a key store. It will where server will have its own certificate. Okay, and server will also have a trust store, and the trust store of the server would contain the certificate from the client to make sure okay this client is also valid one. Okay, so into a TLS it will make a call to access resource. Server will present the certificate, client will verify the certificate. So that is pretty much similar to what happens in one-way TLS. So that is one thing. Now after verification of the certificate, client will present its certificate, server will verify the client certificate from the trust store which it has maintained. From that trust store, server will verify okay client certificate is also valid, and then after that they will transfer the data. Okay, the data transfer happens. So that process happens every time. Now there is also a connection keep alive property in HTTP. Okay, so what happens for a certain duration, like for time 10 minutes, 5 minutes, or 1 hour, this verification, because every time this verification happens, this takes time, right? And this is a time consuming thing. Every time you verify a certificate client or whatever, so it will have a adverse impact on performance. Now to avoid that adverse impact on performance, there is a HTTP has a header keep alive header. Okay, so by default this keep alive header is enabled. So for a certain duration like 10 minutes, 15 minutes, or 1 hour, once the verification is done, okay, server will not verify the certificate from its own client, or client will not verify server from the certificate from server for like next 10 minutes. So only for the first call it will verify, and for that next 10 minutes or 1 hour, only data transfer will happen. They will not have to verify that because they have verified and established the connection. Okay, now verified the client and I have verified the server, both are good and they don't have to verify it anymore. Okay, so that way in two-way TLS also you don't have to verify for every request. Now once you verify for the first request, it will be valid for a certain duration, and during that duration they don't only transfer data. So that way it can happen faster. Otherwise every time if you keep verifying, the performance will be impacted in a very bad way. Okay, so that's how you may still maintain a good performance even with the two-way TLS. Okay,
Okay, fine.
and it same happens even with the one-way TLS. So once for the first time when you are hitting your Apigee with the browser, or for the first time you are hitting Apigee with your this thing Postman and all, for certain time after till certain duration, it will not verify your certificate again. So it will verify for the first time, and it is everything is valid, then it can be trusted. It is there is no problem with that. Then it will not verify for like next 10 minutes, 15 minutes, or two whatever certain time. Okay.
Okay. Yes, if we allow the key, that means if we enable keep alive, so will it lead to any
We don't have to
security
enable
concern?
that is a by default it is enabled. Keep alive is by default enabled as a part of HTTP protocol itself.
Okay. So will it be the time will it be changeable or otherwise is it fixed?
We cannot change it. That is on a product level. So Apigee, the Apigee operations, the product team, it manage on their level. So we are not supposed or not allowed to change.
Okay, so APG administrators also they are not, that means they cannot
No,
change it, right? Only the
no,
product
yeah,
support they can do.
support. Yes, only those two.
Okay, okay, fine, fine.
When so that is the reason when we create a virtual host, which is the secure virtual host, okay, which is on HTTPS. So when we create a virtual host which is using HTTPS, for that virtual host we have to always have a key store. In the key store it will have Apigee will have its Apigee certificate and private key. So that is the reason, because obviously Apigee has to present its certificate to the client every time from the virtual host. Okay, so when you create a secure virtual host, you have to create it, or any virtual host, not just secure but any virtual host which is going to use HTTPS URL, then you have to present a key store and a key alias. Okay, so there you are going to store the certificate and the private key. Okay, so that whenever someone tries to authenticate it's any client, you will present the Apigee server certificate to that client. Okay, so a virtual host on the secure or HTTPS protocol will have a key. This key store things, and a virtual host which is on a simple HTTP, they don't have to worry about any such thing. They can simply they don't need to have all this information related to SSL and all. Okay, so they won't have anything. They don't need to worry about key store certificate because HTTP is unsecure protocol, so you don't have to worry about the certificate and key authentication. Okay? And this is what I was saying. So in HTTP 1.0, this keep alive header was not present. We had to manually set in the HTTP 1.0 protocol, but HTTP 1.0 is not used anymore. Everyone uses HTTP 1.1 or higher. Okay, so by default, as the latest standard, as per the latest supported version of HTTP protocol, this is enabled by default. So all the connections are persistent. So you don't have to set this connection keep alive manual, or you don't have to manipulate that header. Okay, by default, these are set. Okay.
Okay.
So yeah, that's so this is like when you want to create a virtual host using Apigee management API, you can specify all this information. You have to put a key store and trust store there, so that all the clients of Apigee verify okay Apigee as a server, and they can say okay this is like this is a valid server from a valid certificate from Apigee, and Apigee host name is valid, and it is not a unsecured thing. And when you want to secure call to backend, so as I mentioned, in the backend, the most preferred way is like two-way TLS. But sometime what happens is from Apigee to backend also, we can do this by based on credentials, or then there is we can also do an OAuth from Apigee to server as well. But that's a big. I mean, we try to avoid it as much as possible, to be honest. Okay. And then there is always an IP whitelisting, but right now IP whitelisting is not the most secure way, because people can spoof the IPs, and IPs also keep changing. If backend is also on the cloud, IP is also on cloud, and IP keep changing for the cloud, and also then there is a bit of problem, because cloud systems, the IP is not a static one. So from Apigee to target, most likely we always do the two-way TLS. That's the most common way. Okay, and that's the way. So when we are trying to secure the communication from Apigee to backend, we obtain the certificate for Apigee Edge. So we generate the Apigee certificate and key, private key, using some trusted provider. So this thing, trusted certification authority, and that is a big process which can take up to 1 day or 2-3 days depending on the process. And then once we get the certificate, we provide our certificate, only certificate part. We don't provide our private key. Private key is always on the Apigee Edge. Apigee will never provide the private key to other. Apigee will simply give the certificate part of that this thing. So Apigee will give it certificate and give it to the backend team. Backend team will then store the certificate of Apigee on their trust store, and Apigee will get the backend certificate if needed on the trust store, and Apigee will create a key store. In the key store, Apigee will store its private key, and Apigee will store its certificate. Okay, so the key store is always for Apigee private key and certificate. Trust stores are always for the whoever is the opposite party, or the front in front for which we are going to deal with. So that will be there, and then we can specify all this information on target endpoint as well, and we can also specify this information in the target servers. In the target server also we can specify all this information, and then we can go ahead with our communication.
And this certificate, who will provide this certificate? Apigee itself provide, or otherwise do we need to take it
No,
from third party?
we have to usually for an enterprise environment. Okay, we don't use Apigee provided certificates, because those are like only configured for apigee.com domain. So we want to have our own domain, like your api.vodafone.com, for example. For Vodafone, you want to have
Okay.
api.vodafone.com. So what happens is Vodafone, for Vodafone there will be one team which will log a request with the some certification authority. Certification authority like VeriSign or something. There are some dedicated certification authorities for internet. Okay, so those
Yes.
trusted certificate authorities, someone from Vodafone organization would request for that. They will verify it is coming from Vodafone. They need to provide a Vodafone email ID, contact number, company registration details, right? Company registration details, everything they will ask for that. Then they will verify, and then they will issue a certificate. So that's how it goes in real life. Okay, be done in one way, or it can be done in 2-3 days, depends on how long it takes.
Yes, yes. That certificate we need to install both in APG server and client. That means yeah, target system,
Client
right?
target, yeah. So target, so they will provide two things. They will provide a private key and certificate. Okay, remember.
Okay.
So private key we will have it on APG. So private key and certificate we put on our APG layer in the key store. Okay, and only
Okay.
certificate part we provide to backend. Okay, private keys are never shared with anyone. So only certificate of all certificate we will provide to the backend system. Okay, this is our certificate. You put our certificate in your trust store, and you give us your certificate. Your certificate I am going to put in our trust store. Okay.
Trust.
Yeah.
Great, great. So here that means if we use enterprise provided certificate, okay. So do we need to delete the existing APG certificate? APG certificate?
We don't need to delete. We can create a new virtual host or new this thing key stores. Okay.
Okay, okay, okay. Fine, fine, fine.
And at the time of API deployment, you always have an option. If you have, it will give you option of multiple virtual hosts, right? Sorry, those virtual hosts. So you don't have to select your default and secure. You can simply select the new virtual host now which you have developed, like api.yourdomain.com. Okay, something like that. So it will deploy there. All right.
Yes, yes, I got it.
So moving ahead, this is the same thing which we discussed right now to configure this. As we have just seen now transport layer security and everything. Now there is the next thing which we are going to discuss is data masking. Now what happens is even on the Apigee Edge, when the request comes, you can see all the request headers, you can see all the payload things and all, right? So payload parameters and everything. Now but sometime due to security reasons we should not be able to see something like credit card numbers or any personal mobile numbers, any personal detail of the user for security and compliance reason. Okay, so in order to implement that, by default Apigee never shows you authorization header, right? As you can see, authorization header always you can see star star. Okay, client IDs also sometimes they use it in the star star. So all these Apigee automatically enables by default as a star star, so you never see them on the Apigee trace. But sometimes, obviously, for compliance and security requirement, you should not even see some other information like the credit card number and other sensitive data. So in order to enable that, we have to create a mask configuration. So mask configuration will specify these things should never be shown on the trace. Okay, it is only for the trace. So in the trace, especially in production environment, because in non-production environment you are doing testing and all you can do for your test data, but in production environment, for obvious reason, anyone who is having access to Apigee trace, even if he is doing the troubleshooting whatever reason, he should not be able to see all this sensitive information which is coming in the request or going back in the response. So in order to hide the sensitive information to be shown from the Apigee trace, we enable a mask config. So mask configurations can be enabled using the management API. So in the management API, you have to make a call and you have to give name of the all the parameters, all the fields. Okay, so you can mask values in the XML payload, you can mask values in the JSON payload, you can mask some APG variable names and all. So you can mask all these details using mask config. So once you do the mask config, after creating the mask configuration, anyone who is going to use the trace would not be able to see. Mask configs are done on two level. One is on organization level. So if you are doing on the org level, all the proxies and all the environments, okay, in the org will honor that. Okay, so all of them, it will be applied on all the whole org level. Okay, another option is on the proxy level, because you have one proxy which is like for payments. For example, you have one proxy for payments and you don't want anyone to see all the sensitive data in payments. Okay, you have another proxy which is like common, which is like not having any sensitive data and all those stuff, and you don't want to enable this mask configs for that specific proxy. So you can create the mask configs on the proxy level as well. So so in that you have to give the org, then API name, and then mask config. Most likely we do that on the API level, because not all the APIs would have the requirement for mask config. Or another option is the hybrid approach. So some things which will come for all the proxies, it is going to be common for multiple proxies. and you want to hide it, you don't want to do it on API level because people might make mistakes. So what you can do is, for some things which you know is going to be common across multiple proxies, you can do that on the org level, and some of the things which you want to do only on the specific proxy, you can do on the proxy level as well. So there are management APIs available, you can utilize those. And this is a simple request when you want to make a call to mask config API, management API. So certain things you can specify. So as I mentioned, you can do it for the XML. So there is XPath. So in the XPath, you can specify that, and in XPath request, XPath response, JSON path of the request, JSON path of the response. Even in the fault payload, in the fault is in the fault also, or in the JSON fault also, if there is something wrong in the fault, if you want to block that to be shown from the trace, you can do that from the fault. Okay, so you can specify all this information, and even in the last, if you see there is a variable, so in the variable you can do it from the request header, you can do it from the request form parameter, anything you can do for this thing. So in the Apigee trace, when it shows on the Apigee trace, if you see downwards, your login password, if you see, it is showing as a star, so it will show as a star, so it will not be shown on the trace, it is masked, but the real value is still getting passed. Okay, so that's how you hide sensitive information to be seen on the runtime on the traces, especially on the production environment. Okay,
Where did you mention here mask concept? Where did you mention in this code?
so we don't have to mention in the code, we have to make a management API call. So like for example, in the management API, let me show you.
Okay, there only.
Yeah, so in the management API, you make a call. In the management API, you will can get the mask configs, and then automatically it will be shown. So there is a data mask section, if you can see here.
Okay.
So there is a create a data mask for an API. Using that, it will create a data mask for an API, and in that you can specify all of them for that whatever things you want. So it is like a one-time activity. You don't have to do it. When you do it using management API, you are done. Then you don't have to worry anything. Automatically it will be applied on your proxy. Okay, you don't have to do anything on the code level and all. You can go ahead with your coding as you do in the normal. All right.
Okay, so for example, if I do the that means if I call API proxy through masking, okay, so in later if I don't want to mask it, okay, so in that case, should I do any changes in code, or otherwise should
There
I
is
call?
you can also you can do a delete. There is a delete as well.
Okay, delete data masking.
You want to delete it, you can even create, you can delete. So there are APIs for management API call, so you can use these management APIs to create or delete the mask config. Okay,
Okay, fine, thank you.
yeah. And you can also check list of all the mask configs which are there, or you can also check the list of all the masks you have done already. Okay, so you can do that as well. So accordingly you can manipulate later on based on the business requirement, you can manipulate that.
Yes.
Another option, another thing which we do is like API whitelisting or blacklisting. Okay, so using API whitelisting, sometimes if there is a requirement that you have to whitelist based on certain IPs for the client. This is like for incoming request. From incoming request, you want to allow or deny the request based on the IP. You can use IP whitelisting. This is not an ideal approach, to be honest. When there is a, as you mentioned, if there is a cloud system which is there, okay, and in the cloud the IPs are not static. IPs will be sometime dynamic. IPs can change. So we avoid using this thing. But sometimes if there is a requirement from the business that okay, we know that their IPs are they already have like 2 or 3 public IPs, and we know that we want to allow only those or 2 or 3 public IPs, and there will be no change, etc. So based on those business requirement or conditions, then only you allow this IP whitelisting policy. Okay, so that in IP whitelisting you provide the rule like you want to allow or you want to deny, and this thing, if this rule is going to match, then you will deny. So basically if the IP is coming from this 1010 whatever, then you will deny. Everything else is allowed. So based on this, you will you are only going to deny this 10.10.10.10. But you can do the opposite. So you only want to allow from a certain IP, so your match rule will be allowed, and no match is denied. So when your match rule is allowed, then you only allow certain set of IPs. So that way we can do IP whitelisting or IP blacklisting based on that. But yeah, because IPs can be spoofed as well. So people, if there are some hackers and they can spoof the IPs and all, we prefer it not to use only and this is used only when there is a specific requirement from business and they are pretty much sure and they know that this is OAuth and all are sufficient, and obviously you have the TLS verification. So that is the most common approach. IPs are, these are like things of old, but many times in enterprise environment you want to do that, then you have to do it. It is most likely to be used in a scenario when your calling system is either from a partner. Okay, so you know that these APIs are only for a certain partner and these are their public IP. It is useful in that. Another use case will be when it is from your own internal system. So you know that okay, some your own internal company application which is going to call, and they have this kind of IPs, and you don't want even your other internal systems to call, then only you do this. So these are the two very specific scenarios when we use that. All right, that is one of the standard gateway use cases, that it has to provide a ability to do rate limiting from the incoming request. Okay, in the traffic management policies, it will allow you to configure cache or control the traffic quota, apply rate limit and all. So you can see this. This rate limiting policy will give you a control on the raw throughput, the total number of requests that you can process on Apigee, and you can also configure your traffic based on each client. So you want certain kind of clients to have like 100 requests per minute, and another set of client you want 500 per minute, you know. So that also you can enforce using these rate limiting policies. And there are multiple rate limiting policies. Each of them have a specific use case, and we will see those use cases, and we will also have a lab sessions for implementing those. And apart from the rate limiting policy, Apigee has a caching policy. Caching policy is to manage the traffic and protect the backend from making bombarded with too many requests. And in a specific use cases, when you know the response is not going to change from the backend and you want to cache the response for a certain time in Apigee layer, you can do that. So that way you are limiting the number of requests going to backend using the cache policies, and obviously it is done for a performance reason. Okay, so first thing is the spike arrest policy. So spike arrest policy is used to protect your backend from getting hit from the too many requests. Okay, so spike arrest policy is like it will if there is a certain spike in the request, right? There is for a certain duration you are getting like a consistently like 10 requests per minute. Now suddenly for certain duration it becomes 1,000 requests per minute, right? And your backend is not equipped to handle that kind of traffic increase suddenly. So you use a spike arrest policy, so that you know that okay, my backend capability is this many number of requests per minute or per second or whatever, and I have to apply this policy to make sure for the backend request it never increase beyond that limit. So you protect the backend against the certain spike in the traffic in the incoming request. Okay, so this is more of a technical requirement. So spike arrest is like more from a security, and there will be one question in your Apigee developer exam, that which policy is used to prevent the DOS attacks, or what is the best for the spike arrest. So there will be question like, if you want to protect your backend for sudden increase in traffic, so spike arrest is the answer. So that will be one question which is a very common for Apigee developer certification exam. So you can make a note of that. So spike arrest is directly related to the DOS attacks. So what happens is the DOS attacks are basically any client or any unauthorized or authorized client. He will try to send too many requests to your application. It will try to bring your server down, so that the actual valid users of your application are also not going to not able to access your APIs. So they try to make too many calls, like brute force attacks. They will bombard your server with lot of requests. Then this and spike arrest policy will prevent against those kind of attacks. Okay, so if you see a spike arrest, automatically everything is logged in your analytics as well, and Apigee has some good monitoring and all. So if you see too much spike and all, then you can take informed decisions. You can block that particular user agent or particular IP, or you can take action against it. That also you can do that. So this is so that way you are protecting your system and your backend against the sudden increase in the traffic. Okay. So usually the spike arrest limits are set based on the consultation of the business teams. So and also it is done with the consultation of your backend team. So your backend team of the backend services or backend APIs would let you know, okay, this is the maximum number of traffic or maximum number of requests we can handle. Okay, and accordingly you set your spike arrest limit, and it should be in consultation with business. The business should tell, okay, we are expecting these many calls, and this is the highest limit, this is the lowest limit, so of the calls that we expect, or this is the average traffic, and in accordance with all those, you set your spike arrest limits. Okay.
Okay.
Yeah. And spike arrest does not maintain any time bucket. So because it is like it will go to the rate of the at which the traffic is coming, it will not count like, so it will not have a bucket of 1 minute. In this 1 minute how many requests, or in the next 2 minutes how many requests. It will not do have a time bucket. So that is one of the things. So another question which comes which can come in Apigee certification exam, that which of these policies will have the time bucket of the request or something. Spike arrest will not be that. Usually the quota policy that we are going to see, those quota policies use all the time bucket or get the count on the request. Okay, spike arrest never does that. So it can come in either way. Which policy doesn't do that? So in that you have to select the spike arrest, and which policy do that, then you have to not select spike arrest. So there may be another question, which is that from very pretty standard and common questions which can come in APE certification exam. Okay.
Okay. Means it is number of requests at any point of time, right? So that is hitting.
Yeah.
That is
Spike
maximum
arrest
number of
always goes
requests.
to a unit. Spike arrest always goes to a unit of this thing. So the thing is that you have, like, in a spike arrest, if you configure 60 requests in 1 minute, okay, in a spike arrest policy, if you configure 60 requests in 1 minute, the spike arrest will allow only one request in 1 second. It will go to the second level because it will not maintain a counter for the 1 minute. Okay, it will go to a single request level. Single request, how much time? So it will go to in 1 second. If you make the second call, it will fail. That's the property of a spike arrest. Okay.
Okay. Okay. So
You
the,
correct.
every second it is one request. That means even if you make two requests, then it will get failed.
Yeah, quota is just opposite. So if you have 60 requests in 1 minute in quota, it will make sure
Then
the 60 requests are coming. Those 60 can come in the 5 second, initial 5 second. So it will allow
yes.
like second or third request. Even you have all the 60 in 1 minute, 1 second, it will allow. Quota will not break until it reaches the maximum limit. Okay. And this will go
Okay.
to the, so that is the difference, and that is why spike arrest is used to protect the backend, this thing, and that is why it is a technical requirement. So you, if there is any sudden increase in traffic, you prevent it from going to backend. Okay, so you
Okay.
prevent. So in the spike arrest policy, you have to configure these three things. One is your identifier. So identifier will be like you can specify user agent, or you can specify a client ID, any kind of identifier based on your business requirement. Identifier is an optional attribute, so we might or might not. We sometimes do it on the whole proxy level, so we don't provide anything on the identifier. Okay, so based on that, the identifier is like a unique identifier for the request. Then you can have the rate. So rate will be like the actual rate that you want to do. So like 60 ps. So you have like ps or pm. So spike arrest is either on the second or minute level. It doesn't go on the too much of that higher this thing. So either you can give 100 ps is like 100 per second, or like 100 pm is like 100 per minute. And as I mentioned, so it goes to the internally, it goes to second level. Then what happens, so in the rate you give the actual value, what the rate you want to apply. And then there is a use effective count. So use effective count is basically, as there can be multiple message processor in Apigee, right? So you can have 3 message processor, you can 5 message processor, it can be distributed, right? So there can be multiple message processor. So spike arrest by default is applied on per message processor level. So it is on a per MP level. Okay. So when you give like one request per second, okay, so effectively it means one request per second in per message processor. Okay. So then what happens is, if you have 5 MPs, okay, so it will allow 5 requests per second for each of the message processor, okay, because it is not it is done on per message processor level. Now if you want to do it as a combination of all of them, okay, on your proxy level, for example, you want to do including all 5 of them, I should allow only one request. Then you have to use uh, this parameter, use effective count. So use effective count, if the use effective count is true, then it will do the combination of all your requests across all the MPs, okay, and then it will apply limit on that. All right, but use effective count is possible only when you are defining the limit on the per minute level. Use effective count will not work on the per second level, because it has to maintain a counter which is like on a across the MPs, right? So it has to maintain a centralized counter, and centralized counters cannot be maintained on the per second level. A centralized counter, it will maintain in the minute level. So if you have a PM level rate limit like 600 PM per minute, kind of this thing, or 1000 per minute, then only you, and if you want this 1000 per minute to be up applied across all the message processor, then you use the use effective count.
Okay, so here one question. If I use 1000 per minute, then 1000 requests can I use within 10 to 15 seconds, or otherwise
No, one,
it will divide in another level.
it will it will go to per second level. So we have 1000 per minute, so in the per second it will divide by 60. So 1000 like divided by 60 whatever in a single second, and also that is like per MP. So in a single MP in 1 second it will allow that much.
Okay,
Okay.
so always it checks in second level only, but we have
Yes.
two options. Either we can mention per second or per minute level.
Yes.
Okay, fine.
Now moving on to next one, we will have this PyCrash and all. After this, we will have the lab as well. So we'll use PyCrash, quota, everything. We will see how they work. Okay. Next is the quota. So quota is basically done on the business limit. There is a requirement from the business side, then only we implement quota policy. Quota will, as we discussed. So if you want a certain kind of application, so you have like gold membership or you have a bronze membership, and you want certain kind of applications to have like 100 requests per minute, certain to have 500 per minute, you want to have 1000 per minute, so those kind of things, those kind of limits you can apply using quota policy. Okay, and quota policy will make sure that those number of requests are applied. So it will make sure that even if you make all those 100 calls in like 10 second, 15 second, it will allow all of them. Okay, so that's the it has a business limits, and spike arrest is a technical limit. So that is a differentiation between those two. Okay. So this quota policies, the quota policy use bucket of the request. So they will have the bucket. So obviously they will have the 1 minute of kind of, if you have 1 minute, it will give you a 1 minute of bucket. In that 1 minute of bucket, it will allow that, and then it will, once the limiter cross, then it will wait for that minute time to expire. So you have expired like your 100 request in 10 seconds. So for next 50 seconds, you cannot make a call anymore. Next 50 seconds, it will, after next 50 seconds, for the next 1 minute, again your limits are refreshed, so then you can make another call, the kind of this thing. Okay, so quota will have its own time limits that you specify, and based on that it will allow or deny the request. All right, so quota will make sure that the limit which you have set, that limit has to execute. So in quota, you specify identifier. So identifier is obviously a unique identifier. Usually we give identifier as the client ID, because the quotas are applied to certain applications, and applications can be identified using client ID. So in the identifier, we mostly provide the reference to the client ID. Allow is like the number of requests, the 100, 200, 300, whatever the actual numerical value. Time unit, these are multiple options: month, day, week. So quotas can be for a monthly quota, weekly quota, because this is where you based on your business requirement, you allow that. And then internal interval is like you want to do in 1 minute, or you want to do for every 5 minutes or 10 minutes. So for example, you can have quota for 6 months as well, rather than 1 month. You want to apply the quota for 6 months, so you can specify interval as the 6 and time unit as 1. So that quota will be allowed for 6 months. Mostly we provide the interval as 1. The most standard use case will be 1. So in 1 minute you want to allow that many request, or 1 day or 1 hour you want to allow that many request, it will do those things. Okay. So in quota there are more parameters, as you can see. In the quota there are certain value of counters. So quota counter is like when you want to start the counter, how you want to start the counter. So quota counter or calendar. Calendar is like you want your quota to start using to apply on a particular time. Okay, well, at 4 p.m. or something like that, the quota counter will start from that particular time. Okay, and then rolling window is like it will be reset based on your interval and time unit. So when you deploy the proxy, from the time the interval and time unit starts. Okay, and then flexi is like it will start when your first request comes. So you deploy your proxy at 5 p.m. but you are not getting any traffic. After like 1 hour or 2 hour you got the first traffic, and then your quota counter will start at that time. So these are the three options, three kind of counter types. Okay, so based on whatever you specify, we will see in the lab as well. So in the code automatically it will say. Okay, so if we don't specify calendar, most likely we prefer to use flexi, because we prefer to start counter when we are receiving the first request from our client identifier. So that will satisfy most of the business scenarios. Then quotas can be either distributed, or quotas can be for per message processor as well. So quota, you can apply the quota on per MP level, but that is too risky, because since it is a business limit, you want most likely you would want to make sure that including all the 3 MP or 5 MPs that you have, the quotas are maintained centrally. So it will count the total number of requests on the proxy, not just for per MP. So you can put the distributed as true, so that you will have a centralized counter, and then every time the request comes, the counter is updated. So there is synchronous flag or synchronous tag available, which will do those things. And then because if you do it synchronous, it will have a toll on your performance. So because every time you update your counter, it will take time. So quotas can slow your system. So sometimes what people can do is, you want to update your counter every 10 seconds or 5 seconds. So then you can have a asynchronous configuration where after that particular interval the counter will be updated centrally. So people can do that, but most likely if you want to strictly apply a business limit, you will prefer the distributed as true, so that your quota limits are applied on particular number of requests across all the MPs, and synchronous should be true, so that obviously whenever every request comes, it applies. So there is a trade-off. So it will have an impact on your performance, but obviously if you want to apply your business limit strictly, you don't want anyone to cross the limit that you have given to that client. You need to put the synchronous as true. So that is the most common use case for these quotas. Okay, but there are options, and but I have never seen or received any requirement of using asynchronous config and all. So there is a small, so there will be few milliseconds of delay, but these few milliseconds is not really a big thing. So Apigee is quite fast in still maintaining the distributed quota. Apigee is still quite fast. So it just a few milliseconds of delay, but obviously it will not have that much impact. But obviously there is some impact on performance, but not that much, and still you can apply those things. Another one is the concurrent rate limit. So concurrent rate limit is the policy which is quite new in nature, and to be honest, on the business use case scenario, I have never used at all, or I have never seen anyone using this concurrent rate limit policy. So concurrent rate limit policy will throttle the inbound connection from your Apigee to the backend. So it will check how many connections are open. So just some time back we had this connection thing, right? In the 2 TLS we had the connection keep alive and all. So how many connections are open? So you want to limit the number of open connections from Apigee to backend. You can use this concurrent rate limit, but it is very hardly that I have seen this concurrent rate limit. So it will just check the number of open connections between Apigee to backend. A concurrent rate limit, as it is between Apigee to backend, this policy is always applied on the target system, on the target XML. It is never on the proxy default.xml. Okay, so on the target file we apply this policy if at all. But to be honest, you have the quota, so the quotas will make sure that every client will have allotted number of requests and they don't cross that limit, so that's why those two are more than enough to satisfy any business requirement. This concurrent limit, it has its own implications, because then it checks the number of requests, number of open connections every time. So this policy has a very big impact on performance, and as compared to other two policies, since because it has performance impact, it is never advised to use that. But if there is a client which is very limited in the number of open requests and all those stuff, then you can use this concurrent rate limit. It will just check the open connections, and if there are more than one more than the specified number of open connections, it will block the request. Okay. But most likely in a normal enterprise scenario, the backend targets are very good, and they can be scaled up to handle like thousands of requests per second and all. So this in the real scenario, this policy is never used at all. But Apigee has it just in case someone asks you to use this thing. So, but in Apigee itself, it is never recommended, and it comes with a warning. It comes with a warning that it has a negative impact on performance.